Hello all, in today's video we are going to learn about the different socket options available. There are various types of options available on a socket. These options basically control various behaviors. They can be set using the set socket option and they can be retrieved using the get socket option. There are various ways to get and set the options that affect the socket. They include the get socket option and the set socket option, as well as the file control function and the input output control function. Let us see the syntax of the get socket option and the set socket option functions, which include the following parameters. The socket file descriptor, which is an open socket descriptor. The level specifies the code that interprets the option, whether the option is a general specific code or it is a protocol specific code. Then the option name itself, and then we have a pointer to a variable which will have the new value that is to be fetched or stored, and this specifies the length of that particular variable. Same is the case with set socket option, where we will be setting a particular option specified by the option name. Both these functions will return 0 on OK and -1 on error. Then we have the file control operation. We have the input output control operation. Coming on to the options. The first option is socket broadcast option, which enables sending of broadcast messages. That whenever an application would like to send broadcast messages, it has to set this option. Then the socket debug option. This option is basically used only for TCP protocol, where it is used to track the detailed packet information for debugging. Then we have the socket don't route option, which basically bypasses the normal routing of the outgoing packets. It is useful for routing daemons, where routing daemons are the programs that run in the background performing various tasks without direct interaction from the users. Then we have the socket error option, which cannot be set, can only be read or fetched, where it will fetch the pending socket errors. Then we have a socket keep alive option, which is used to detect whether the peer host is crashed or is unreachable via periodic probes. If the host is reachable, it will respond immediately. If there is no data exchange across the socket for at least 2 hours of time, then the TCP will send a keep alive probe looking for a response from the receiver. If the receiver gives an acknowledgement, it's okay. Otherwise, if the receiver responds with a reset, then it means that the host has crashed and has to be rebooted. But if still there is no response after 8 probes, where 8 probes are made with 75 seconds apart, each probe made 75 seconds apart, then we will wait for another 11 minutes and 15 seconds, and then the connection will be closed. The connection is going to be closed. Basically, this keep alive option or the keep alive probe is used for closing the half open connections. For example, a server got a request for connection from a client, but due to something this host has crashed. But still the server has maintained a half open connection waiting to listen from the client. That is not going to happen. So to close all such half open connections, we make use of the keep alive option. Then we have the socket linger option, which basically is used with the close function for connection oriented sockets. See, whenever we establish a connection between connection oriented TCP or stream sockets, we make use of close function to close the connection. If this option is off, if it is not set, then the close function will immediately close the connection. But if it is on and the value is 0, then it will abort the connection, discards the unsent data. Whatever data was to be sent, it will be discarded because you have aborted the connection. But if it is on and the value is some positive number, that is positive linger, in this case, though a close connection is initiated, it will block this close function until the data that was sent is successfully received or acknowledged, or there is a timeout. So we are going to linger around until the data is received successfully. Then we have the socket out of band inline data. That means this option will place the out of band data on the normal input queue. We have inline data, which is in-band data or inline data. Now, if you have some urgent data which is out of band, this option will allow this out of band data to be in the normal input queue. Then we have the socket receive buffer and socket send buffer. Every socket will have a sending buffer and a receiving buffer. The sizes of these buffers are set using the options socket receive buffer and socket send buffer. Then we have another option which is socket receive low watermark and socket send low watermark. These options are used to set the watermarks for the select function triggers. It means that this watermark will specify how much amount of data should be available for the select operation to make a read, and the socket send lower watermark specifies how much amount of space should be available so that the select function can initiate a write operation. Then we have socket receive timeout and socket send timeout. These both options are used to set the timeout on socket receive and send operations. Then we have a socket reuse IP address and socket reuse port number. This option allows us that multiple sockets can bind to the same IP address or the same socket address under specific conditions. Then we have a socket type option which returns the type of the socket, whether it is a stream socket, datagram socket or a raw socket. We have an option socket use loop back, which will receive a copy of everything sent on the socket. See, whatever is being sent on that socket, a copy will be received. So these were the options these were all the general options that can be get or set using the get socket option and set socket option. Then we have, as I told you, that the level field specifies whether it is a general specific code or the option is specific to particular protocol like IPv4. So we have IPv4 socket options here. These socket options are processed by the IPv4 protocol. That is why they are named as IPv4 socket options. If you will look back to the IP datagram format, there we had some options, IPv4 options. These options are set using these socket options. IP header include. This option is used to build your own IP header. IP options. This will allow setting IP header options. IP receive the destination address. This option returns the destination IP address of the received UDP datagrams. IP receive interface index. This option will return the interface index where the UDP datagram has been received. Then we have the IP TOS, where this specifies or sets the type of service that is provided in the IP header. Is it either high throughput, high reliability, low delay and low cost? What kind of type of service is provided? Then we have IP TTL option. This option will set and fetch the default time to live for a particular datagram in a network. So these are all the different options we have on sockets, which are general purpose sockets, and we have the IPv4 socket. In the next video, we are going to learn about IPv6 socket options and TCP socket options. Thank you.